Hi, in this video we are going to talk about space time and space velocity. So far, we have spoken about ideal batch reactors, and we know that the performance equation for the ideal batch reactor is characterized in the form of its reaction time T. Okay, this is for batch reactor. But when we are extending our understanding of performance equations to the concept of flow reactors, then we have to introduce some new terms instead of the reaction time or batch time. Those two terms are space time, which is designated as tau. So, space time, and the other one is called the space velocity, which is designated as small s. Space velocity. So remember that the concept of space time and space velocity is applicable to flow reactors, whereas the concept of reaction time is applicable for batch reactors. Now let's talk about what these are exactly. Okay, so first we'll talk about space time or tau. Tau is also the reciprocal of space velocity, and it is defined as the time required to process or react one reactor volume of feed measured at specific conditions. Okay, so the time required to process 1 V or reactor volume of feed measured at specific conditions. Remember, this is very important, specific conditions. If the conditions are different, then the measure of tau also becomes different. Okay, and the unit for this quantity is time. Okay, so it can be second, minutes, hours, whatever is your process, like the requirement of the process. Now let's talk about space velocity. So space velocity is small s, and that again is the reciprocal of tau or the space time. So this is defined as the number of reactor volumes of feed at specified conditions which can be processed in unit time. Okay, and the unit of this is time inverse. Okay, now let us understand this concept with an example. Okay, let's say okay, let me just scroll up a bit. Let's say that the space velocity of your system is 5r inverse. What will this mean? So seeing the definition of your space velocity and space time, as I have discussed so far, you can pause the video now and you can just test yourself that what it is. Write it down in a paper and then you can start watching again. Okay, so in case you have paused the video and decided what 5r inverse of space velocity means, let's now see what it actually means. So it means that 5 reactor volumes of feed at some specified condition is fed to the reactor in 1 hour. Okay, so 5 reactor volumes of feed can be at some specified condition can be treated in the reactor in 1 hour. that is your space velocity of 5 r inverse. Now if you have a tau of 2 minutes, what does that mean? Again, here I will request you to pause the video and take a moment to say it for yourself, to test it for yourself from the definition of tau or space time, as I have discussed over here, that what does a tau of 2 minutes actually mean. So hoping that you have tested yourself, let's now see what tau actually signifies. Tau of 2 minutes mean that every 2 minutes one reactor volume of feed at some specified conditions is being processed in the reactor. So that becomes your tau. Now let us come to some cautions that you must keep in your mind when you are dealing with the concept of space time and space velocity. Now you may have noticed that I am stressing a lot on this term, specified conditions. Okay, so this caution that I am going to give you is related to the specified conditions. Now when we are studying reactions, we may randomly select the temperature, pressure and state, like whether it's a gas phase reaction, whether it's a liquid phase reaction or a solid phase reaction, and we can choose this randomly to measure the volume of the material that is being fed to the reactor. Okay, so to define that with respect to specific conditions and relate it to, let's say, uh, you know concentration and volume of reactor and volume of feed, or moles of feed entering at a given time, we use certain relations. So we already know that tau equals to 1 by s. Now this can also be written as Ca0 multiplied by V divided by Fa0. Now what is this Ca0? Ca0 means moles of A entering divided by feed volume multiplied by capital V means volume of reactor, and Fa0 is the moles of A per unit time, that is the molar flow rate. Okay, so this is how you can relate tau. Another way to relate it is V by V naught. Okay, so V is the reactor volume, and V naught, over here I am writing it separately, V naught is the volumetric feed rate. Okay, and the reason why we use this term volumetric feed rate is because it is more convenient in when you are doing a practical study using your reactor, that you can measure the volumetric feed rate easily, and this is done at some standard state. Okay, so first caution is measure V naught at some standard state. Especially, you must keep this in mind if you are to operate your reactor in various temperature conditions. Why? Because let's say you have a material. Let's say you have a material. So let's say you have material A, and this is gaseous at high temperature, but it becomes liquid at low temperature. Okay, so then you need a standard state to which you can refer to, or rather I should say a reference state, which will help you keep a measure between these varied conditions through which your reactor goes. Okay, So the relation between space velocity and space time for actual feed conditions and standard conditions can be related. Now how do we relate those? So let's say that actual feed conditions are like I am using this T dash condition, and standard, okay, no, let me say actual feed conditions is T only and standard feed conditions is T dash. Let's say this is the kind of notation that we are going to use. Okay, then how do we relate space time and space velocity? So then tau dash or 1 by s dash, remember prime or dash is for standard condition and no prime or no dash is for actual condition. So tau dash equals to 1 by s dash, and this again is equals to ca0 dash v by fa0, which again is equivalent to tau ca0 dash by ca0, equivalent to 1 by s ca0 dash by ca0. So this is how you can relate the space velocity and space time for actual feed conditions and standard conditions. Now, in most cases, like whatever you will study for your undergraduate course, you will see that we are mainly dealing with space velocity and space time based on feed at actual entering conditions. But if you are extending your understanding for any, say, research application or industrial application, then it is good to know that you have to have a standard reference state to fall back to, so that you do not make any mistakes in calculation of space time and space velocity. That is it. Thank you.